When the compaction work is progressing in the field, it is useful to know whether or not the unit weight specified is achieved. One standard procedure used for determining the field unit weight of the compaction is the sand cone method. Objective of this experiment: the experiment is performed to determine the in-place density of undisturbed soil using sand cone method, ASTM D1556. Apparatus and supplies.
In-place apparatus. It includes the jar, the cone, and the base plate, and the specimen.
Also check for the cone, it can turn the valve easily. Trowel used for digging up soil. Rectangular pan used as a container for soil. Moisture can, a small container for small sample of soil used in determining density.
Weighing balance used for measurement of weight. The sand with the sand density of 1493.5198 kg per meter cube.
Note: the sand should be uniform in size. Ideally should pass through number 30 sieve and retained on 40 sieve. Oven dried. Procedure and experiment. First, measure the dimension of the cone in order to get the volume. Measure the diameter and the height. In order to obtain volume, the formula is 1/3 pi over 4 d squared times height. The other way is to get the mass of the cone with and without sand. The difference is the mass of the sand in cone. In order to get the volume, sand density will be used. Sand cone method. Weight the apparatus, empty moisture cans, empty rectangular pan, and empty cone plus jar. Fill the jar with sand up to 80 to 95% of the container. Weigh the initial mass of the sand plus cone plus jar. Locate a level ground and place the base plate. Dig a hole in the opening of the base plate using the trowel and place every soil at the rectangular pan. Note: it is important not to lose any material. Any loss of material would introduce substantial error in determination of the unit weight for such a relatively small sample. And don't dug too much deep to the point that the sand cannot fill up the entire hole plus cone. Ideally, for the hole to be same depth as the handle of the trowel, place the sand cone apparatus and open the valve until it filled the hole and the cone. At the start of it, you can check if it is flowing by opening it slightly. You can tap the sides of the apparatus to well distributed the sand, but don't ever compress the sand by means of any way. Close the valve when it stops flowing. Also, you can check by tapping the sides of the cone. If its sound is no longer follow, meaning it is already filled. Slowly remove the apparatus and weight the final mass of the apparatus. Weigh the rectangular pan with in situ sand. Once weighed, get a sample and place it on two different moisture cans, which will be oven dried to get the dry density. Weigh the moisture can before and after oven drying it.
Data and results. We have 2 given, which is the density of the sand, which is 1493.5198 kg per meter cube, and cone volume in terms of mass, which is 1.309 kg. We obtained in the experiment are initial mass of jar plus cone plus sand, which is 7.3482 kg, final mass of jar plus cone plus sand, which is 3.7180 kg.
And computed the following: mass of soil from the pit, rectangular pan with soil minus empty rectangular pan is equal to 1.917 kg. Mass of sand in the pit, initial minus final minus cone volume in terms of mass is equal to 2.3212 kg. Volume of the sand by mass of sand in the pit over the density of sand is equal to 1.5542 times 10 to the negative 3 meter cube. Density of soil is equal to mass of soil from the pit over volume of the pit is equal to 1233.4471 kg per meter cube.
Additional data is gathered: water content of the soil and dry density. Sources of error. For this experiment, the errors in the gathered data come from the faulty defective equipment and from mistakes made during the experiment. Some weighing scales are either damaged or broken. Damaged scales can give erroneous data. The sand cones can have sand particles stuck in the gaps, making it difficult to open or close the passage of the weighed soil. Could still have some foreign materials, which could affect its weight. Remarks and recommendation. Volume and density of an unknown soil in the field can be easily determined with the use of the sand cone apparatus, with the specific sand together with the known data of the sand. However, there are some limitation for it. For example, the sand cone apparatus containing a specific sand should contain more than the estimated volume of the pit plus the volume of the cone. The apparatus should be filled with sand more than 80% of the container and controlled in the volume of the pit of the soil for the remarks.
Audio Jungle.